Welcome back to a new lecture in the Prompt Engineering course. In this session, we will continue our exploration of advanced prompting strategies that help improve the performance of large language models. In our previous discussions, we explored different techniques for designing effective prompts. Each technique influences how a model processes and responds to a query. In this lecture, we will continue our discussion by looking at an advanced prompting technique designed to enhance logical reasoning in AI models. This technique, called chain-of-thought prompting, is particularly effective for problems that require step-by-step reasoning. Now let us take a closer look at what chain-of-thought prompting really is and why it works. So, what is chain-of-thought prompting? Chain-of-thought prompting is a prompt engineering technique that improves the reasoning capabilities of large language models by incorporating step-by-step logical reasoning within the prompt. Instead of asking a model to provide an answer directly, CoT prompts encourage it to think through the problem systematically. By breaking down complex tasks into structured steps, this technique enhances model performance across several domains, including mathematical problem solving, where models need to carry out calculations step by step; common sense reasoning, where logical deduction is required to understand scenarios; symbolic manipulation, such as working with equations, code, or logical expressions; decision-making tasks, where multiple factors need to be considered sequentially. This technique was first explored in the 2022 research paper, Chain of Thought Prompting Elicits Reasoning in Large Language Models, by researchers at Google Brain. The study demonstrated that guiding models to articulate intermediate steps significantly improved their performance on arithmetic, common sense, and symbolic reasoning tasks. Now that we understand the concept of chain-of-thought prompting, let us discuss how to construct an effective CoT prompt. The process is simple. To encourage step-by-step reasoning, we append an instruction to the prompt, such as, "Describe your reasoning in steps. Explain your answer step by step." By adding these instructions, we guide the model to generate intermediate reasoning steps before arriving at a final answer. This structured thinking approach is what allows CoT prompting to improve accuracy, particularly for complex tasks that require logical reasoning. However, it is important to note prompting is most effective when applied to large language models. While larger models have the capacity to process and generate well-structured reasoning steps, smaller models may struggle to perform as well. This is because larger models have been trained on vast amounts of data and have more robust reasoning capabilities. By incorporating CT prompting into our interactions with LLMs, we can unlock their potential for handling sophisticated reasoning tasks. Next, let us explore how CoT prompting works. Chain of thought prompting works by mimicking how humans naturally approach complex problems. Instead of immediately jumping to an answer, humans typically break down difficult tasks into smaller, manageable steps. For example, when solving a complex math equation, we do not just state the answer outright. We go through a series of sub-steps, like identifying given information, applying relevant formulas, performing calculations in stages. So, we work through each step logically before reaching a final answer. Essentially, CoT prompting gets the model to think out loud, rather than providing an instant response. Let us now look at a practical example of chain-of-thought prompting in action. So the prompt is, a classroom has 2 blue chairs for every 3 red chairs, and so on as shown in the slide. When we provide this prompt to an LLM using CoT prompting, the model does not just return the answer directly. Instead, it works through the problem systematically, just like a human would, and give final correct answer. This example clearly illustrates how CoT prompting helps the model break down a problem into logical steps before reaching the final answer. It works because it forces the model to think through the problem, just like a human would, rather than simply guessing or relying on pattern matching. Similarly, you can see another example of project management CoT prompt and ChatGPT response on it. This example shows how CoT prompting can be used beyond mathematical problems. It is highly useful for structured decision-making in real-world scenarios, such as project scheduling. By prompting the model to explain its reasoning step by step, we ensure logical and well-structured solutions. Now, Take a look at this comparison between standard prompting and chain of thought prompting in the given slide, which is taken from research paper mentioned below. In standard prompting, the model receives a question and is expected to generate an answer directly. However, this often leads to incorrect responses, especially for problems requiring multi-step reasoning. For example, the first question is about calculating the total number of tennis balls. The model correctly answers 11, but without explaining how it arrived at that number. The second question involves basic arithmetic, yet the model makes a mistake, incorrectly stating that the answer is 27 instead of 9. Now, look at chain of thought prompting on the right. Here, the model breaks down the reasoning process step by step. It explicitly calculates that 2 cans contain 6 balls in total, then adds them to the original 5 to get 11. Similarly, for the apple problem, it clarifies each step, starting with 23 apples, subtracting 20, and adding 6, to correctly arrive at 9. This structured reasoning reduces errors and improves accuracy, especially for complex problems. This is why chain of thought prompting is so powerful, and it helps models think more like humans by following logical steps rather than making guesswork-based predictions. So far, we have explored the fundamental concept of chain of thought prompting and how it enhances reasoning capabilities in LLMs. Now let us look at different approaches to implementing CoT prompting. There are 4 primary approaches. First one is zero-shot chain of thought prompting. Second one is manual chain of thought prompting. Third one is automatic chain of thought prompting. And the fourth one is multimodal chain of thought prompting. Each of these methods has unique strengths and applications. So let's start by exploring the first approach, which is zero-shot chain of thought prompting. Zero-shot chain of thought prompting allows LLMs to generate step-by-step reasoning without being provided with any examples. This is achieved by simply appending an instruction to the prompt, such as, "Let us think step by step." This method follows a 2-stage process. Stage 1 is reasoning extraction. The model generates a step-by-step thought process by responding to the instruction in the prompt. And the second one is answer extraction. The reasoning steps are then used to derive the final answer, sometimes requiring a second prompt for refinement. By prompting the model to explain its reasoning, we can improve its ability to solve complex problems, even without explicit demonstrations. Now, let us see an example of zero-shot CoT in action. So we provide the model with the following prompt. Calculate the ROI for a project with an initial investment of $50,000 and a net profit of $15,000. Let us think step by step, and model give a step-by-step response with the final ROI as 30%. This example demonstrates how simply adding "let us think step by step" prompts the model to structure its reasoning logically before arriving at a conclusion. It works because it forces the model to break down the problem systematically, rather than making an instant calculation that might be incorrect. Next, we will explore the advantages and limitations of zero-shot CoT prompting. Zero-shot CoT is a powerful and easy-to-use technique, but like any approach, it has its strengths and weaknesses. Advantages: easy to use, no need to craft specific examples or demonstrations. Quick setup, works with just a simple prompt, making it accessible for various tasks. However, there are also some limitations to consider. Reasoning can be flawed. The model might generate incorrect or illogical steps, even if they sound convincing. Unreliable answers. The final conclusion may still be incorrect, even if the reasoning appears structured. Because of these limitations, zero-shot CoT is best suited for cases where we want a quick breakdown of reasoning, but for more complex or high-stakes scenarios, we may need a more structured approach. Now, let us move on to another approach, which is manual chain of thought prompting. Unlike zero-shot CoT, where the model generates reasoning steps on its own, manual CoT requires users to provide carefully crafted step-by-step examples. The model then uses these demonstrations to solve new but similar problems. This approach follows a 2-step process. Step 1 is provide detailed examples. Users manually create structured examples that include the problem statement, logical reasoning steps, and the correct answer. And step 2 is LLM applies learned reasoning to new problems. The model generalizes from the provided examples to solve new but related problems. A test question is often included to check if the model has successfully learned the reasoning pattern. Manual CoT is particularly useful when we need to ensure logical consistency and domain-specific accuracy, making it an effective method for structured problem solving. In this slide, we can see that the input prompt includes an example question along with its step-by-step solution. After that, a test question is added to the input prompt. The model then generates an answer by following the structure of the provided example. By first presenting a detailed example, the model gains a clear understanding of the reasoning pattern. As a result, it can apply the same logical approach to similar problems. This makes manual CoT highly effective for structured problem solving, particularly in fields such as business, finance, and technical domains. Manual CoT is a powerful technique, but it comes with both advantages and challenges. Advantages of manual CoT: robust reasoning. Detailed, structured examples lead to more accurate and reliable model outputs. Customizable. Users can tailor examples to specific industry needs, making it applicable across finance, logistics, healthcare, and more. However, there are some limitations to consider. It is time-consuming. Manually crafting effective examples requires effort and expertise. It is not scalable. Since it relies on predefined examples, it may not generalize well to a broad range of tasks without more demonstrations. It needed expertise. The quality of manual CoT depends on how well the examples are designed, requiring deep subject matter knowledge. So far, we have seen Zero-Shot CoT, which requires no examples, and manual CoT, which requires human-crafted demonstrations. Now let us explore a more scalable approach. AutoCoT means automatic chain-of-thought prompting. AutoCoT automates the process of generating examples for the model, eliminating the need for manual effort while still benefiting from structured reasoning. How it works. AutoCoT follows a structured three-step approach. Step 1 is question clustering. The process begins by collecting a set of test questions, which can be sourced from standard datasets or real-world problems. These questions are then grouped into clusters based on topic and structure to ensure that similar questions share common reasoning patterns. For example, percentage problems might form one cluster. Geometry problems might form another. This step ensures that the examples generated are highly relevant to each question type. Once the questions are clustered, the model automatically generates reasoning examples. So the step 2 is creating example answers. From each cluster, one representative question is selected. The model is then asked to solve this question using a simple step-by-step reasoning prompt. This allows the model to generate structured reasoning patterns without requiring human-created examples. Now in step 3, it uses examples to solve new questions. When the model encounters a new question, it refers to the automatically generated examples from its cluster. The model follows the same reasoning structure used in the example to solve the new problem. This method allows large-scale automation of the CoT approach, making it highly efficient for scenarios where manual example creation is impractical. AutoCoT is particularly useful when working with large datasets, adaptive learning environments, and enterprise-level AI applications where scalability is key. In this slide, we see a visual representation of how AutoCoT works. The process begins with clustering similar questions, ensuring that reasoning patterns are grouped logically. For example, a shopping-related question and a cooking-related question might share a similar numerical reasoning structure. Next, instead of manually crafting examples, the LLM generates step-by-step solutions automatically for one representative question per cluster. This is done using a simple instruction like, "Let's think step by step." Finally, the model applies these learned reasoning patterns to solve new test questions, ensuring consistent logical reasoning across similar problems. This approach reduces human effort while still benefiting from structured, explainable problem solving. Now that we understand how AutoCoT works, let us explore why it is so useful. It eliminates the need for manual examples. Unlike manual CoT, where humans must carefully craft examples, AutoCoT allows the model to generate its own demonstrations automatically. This makes the process faster and more scalable. It handles a variety of problem types: Since the model clusters similar questions and generates logical step-by-step examples, it can adapt to different types of problems without requiring additional human intervention. It boosts accuracy through structured reasoning. By encouraging the model to explain its thought process, AutoCoT reduces errors caused by jumping to conclusions too quickly. This makes the output more reliable and easier to verify. It enhances LLM reasoning capabilities. AutoCoT essentially trains the model to think more like a human, improving its ability to handle complex mathematical, logical, and decision-making tasks. With AutoCoT, we get the benefits of structured reasoning without the manual effort, making it a powerful technique for improving LLM performance in real-world applications. Now let's talk about the some of limitations of AutoCoT. So first one is dependence on a high-quality dataset. AutoCoT requires a well-structured and diverse dataset to generate effective reasoning examples. Poor quality data can lead to incorrect reasoning paths and degraded performance. Second one is computational overhead. AutoCoT requires additional computation for generating and verifying reasoning steps, which can slow down inference speed and increase resource usage. And third one is lack of interpretability. The generated reasoning steps may not always align with human logic, making it difficult to interpret or debug errors. Now, let us talk about an advanced extension of chain of thought prompting, multimodal chain of thought. Unlike traditional CoT, which relies only on text-based reasoning, multimodal CoT allows AI to reason using both text and images. This is a crucial improvement because many real-world problems require understanding visual information alongside textual context. How multimodal CoT works. It follows a two-step process. First one is rationale generation. The AI first analyzes both text and images to develop a structured step-by-step reasoning process. And the second one is answer inference. The AI then applies this reasoning to generate the final answer. Why is this useful? It combines visual and textual understanding. This allows AI to interpret complex images, diagrams, or charts in context, improving reasoning beyond text alone. It enhances accuracy in real-world applications. Industries like medicine, engineering, and science often require AI to interpret images, for example, X-rays, design schematics, and lab results, alongside textual descriptions. It improves decision-making. By incorporating multiple data modalities, AI can make better, more informed predictions and analyses. Multimodal CoT is a significant leap forward in making AI more capable in domains where images and text must be understood together. In the next slides, we will explore some real-world examples. Now let us see an example. From slide, we can see the input and output. Input contains language, which is about whether two magnets will attract or repel, and vision, which is a diagram of two magnets with labeled poles. Now let us look at the output. The AI first analyzes the magnetic poles and applies scientific principles to determine their interaction. Based on this reasoning, it concludes. Final answer. Since opposite poles attract, the correct answer is A, means attract. This method improves AI's ability to handle real-world problems that require a combination of textual reasoning and image interpretation. It has applications in science, engineering, and even medical diagnostics. As we move forward, multimodal CoT will continue to shape AI future by allowing models to see and think at the same time. Now that we have explored different types of chain of thought prompting, let us look at some real-world applications. First one is customer service chatbots. Many companies use AI-powered chatbots to assist customers. CoT helps chatbots break down complex customer inquiries into logical steps. For example, if a customer asks, "Why was my payment declined?" a CoT-based chatbot can walk through possible reasons, like insufficient funds, card expiration, or transaction limits, before offering a resolution. This results in more accurate, human-like responses, improving customer satisfaction and reducing the need for human support. Second one is research and innovation. In scientific research, CoT can structure problem-solving approaches. Instead of jumping to conclusions, AI can analyze data, hypothesize possible solutions, and reason through them step by step. This structured approach accelerates discoveries and aids in formulating new hypotheses. Third one is content creation and summarization. Content writers and researchers often need to generate summaries, structured outlines, or even creative writing pieces. CoT helps by organizing information logically, ensuring coherence and readability. For example, if an AI is summarizing a research paper, it can first extract key findings, then structure them into a logical flow, rather than producing a disjointed summary. Fourth one is education and learning. CoT is a game changer in education, especially in subjects like math and science. AI tutors can guide students step by step through problem solving, helping them grasp not just the answer, but also the process. This approach fosters deeper understanding and retention. And the final one is AI ethics and decision making. AI is increasingly used in areas requiring ethical considerations, such as hiring, loan approvals, and medical diagnoses. CoT ensures that AI-driven decisions are transparent and explainable. If an AI denies a loan application, CO allows it to justify the decision, improving trust and accountability in AI-driven systems. These use cases highlight the transformative power of CoT, prompting across industries. By enhancing reasoning, structuring complex information, and improving transparency, CoT is shaping the future of AI-driven problem solving. Now, why does chain of thought prompting matter? Let's go over its key advantages. It improved reasoning capabilities. One of the biggest strengths of CoT prompting is its ability to enhance logical reasoning. Instead of providing direct answers, the model breaks problems into smaller steps, similar to human problem solving. This makes it especially effective for complex tasks like math, coding, and logic-based reasoning. It enhanced model interpretability. A major challenge with AI models is their black box nature. We often do not know how they arrive at an answer. CoT makes AI decision-making more transparent. By revealing its step-by-step thought process, CoT allows users to assess, debug, and refine AI-generated responses. Task versatility. CoT is not limited to one specific domain. It has been successfully applied to arithmetic reasoning, common sense reasoning, and even tasks like symbolic logic. Whether it is a chatbot explaining a refund process or an AI solving a geometry problem, CoT adapts across various fields. Reduction in data requirements. Traditional AI training requires massive datasets, but CoT prompts can work effectively with few-shot or even zero-shot learning. By simply adjusting the prompt, we can get the model to handle multiple types of reasoning tasks, saving time and computational resources. These advantages make CoT a crucial tool for enhancing AI problem-solving abilities, improving transparency, and reducing the need for large datasets. Despite its many advantages, chain of thought prompting isn't perfect. Let's discuss some of its limitations. First one is dependence on model scale. One major drawback is that CoT prompting works best with large-scale models. Smaller models often fail to generate coherent reasoning steps, making CoT ineffective unless the model has a sufficient number of parameters. Research shows that CoT's benefits only become noticeable in models with over 100 billion parameters. This means CoT is mostly limited to high-end AI models, which require substantial computational resources. Second one is risk of error propagation. Breaking a problem into steps usually improves reasoning, but if the model makes an error in one step, that mistake carries through the entire chain. This is especially problematic in Zero-Shot CoT, where the model generates reasoning chains without human-provided examples. If an early step is flawed, the final answer will likely be incorrect as well. Third one is computational cost. CoT requires generating multiple intermediate reasoning steps before arriving at an answer. While this improves accuracy, it also increases processing time and computational costs. Compared to standard direct answer prompting, CoT is significantly more resource-intensive, making it less practical for applications requiring real-time responses. These disadvantages highlight the challenges of CoT prompting. While it enhances reasoning and interpretability, it requires large models, carries a risk of compounding errors, and demands more computational power. Understanding these trade-offs helps us make informed decisions about when and how to use CoT effectively. Now let us see some tips and tricks. We can optimize LLM usages by CoT prompting. Large language models consume more tokens when they perform step-by-step calculations. This increases API costs. However, not all tasks require an LLM. Simple operations like basic math, logic checks, or database lookups can be handled more efficiently by external scripts or smaller models. By offloading these tasks, we reduce costs, speed up processing, and improve accuracy. This approach ensures that LLMs are used only where their advanced reasoning is needed, making the entire system more efficient. Now, second tips and trick is we can enhance CoT prompt with chain of action thought prompting. So what is CoT? CoT enhances chain of thought by making the model self-aware and adaptive. It allows the model to continue, reflect, or explore mid-reasoning, improving accuracy and flexibility. Now let's talk about how we can take chain of thought T prompting to the next level using chain of action thought. First, CoT enhances CoT by making the model more adaptive and self-correcting. Instead of following a rigid step-by-step approach, the model can decide whether to continue, reflect, or explore a different approach. To do this, we use 3 key cues. Continue. This tells the model to move to the next step in reasoning. Reflect. The model pauses to check if the last step was correct before moving forward. Explore. If something seems wrong, the model tries a different approach. By adding these guiding cues, CoT helps the model think more like a human, catching mistakes, adapting, and improving its own reasoning. This method is especially useful for complex problem solving, such as multi-step math, logic puzzles, and ambiguous questions, where a single mistake can lead to the wrong answer. Now, let us explore a more efficient way to use chain of thought prompting, called chain of draft. While CoT helps guide models through step-by-step reasoning, it can sometimes be too verbose, using more tokens and increasing latency. CoT solves this by keeping steps short and dense, just like how we jot down quick notes when solving problems. Instead of writing long explanations, the model focuses on key insights or calculations in a few words. For example, instead of a paragraph explaining Jason had 20 lollipops, gave some away, and now has 12, how many did he give? CoT simplifies it to 20x equals 12, x equals 8. To implement CoT, simply tweak your prompt. Think step by step, but keep each step minimal, 5 words max. Few-shot examples help, as zero-shot accuracy can drop without guidance. CoT is perfect for cost-sensitive and real-time applications, especially when working with powerful models like GPT-4o or Claude 3.5 Sonnet. Use CoT for efficiency on simpler steps and CoT when deeper reasoning is needed. This hybrid approach balances speed and clarity. By integrating CoT, you can make LLMs think faster, stay focused, and reduce computational overhead, making reasoning both effective and efficient. And that brings us to the end of this session. Today, we explored chain of thought prompting, a powerful technique that enhances AI reasoning and decision-making. By understanding these methods, we can craft better prompts, leading to more accurate and meaningful AI responses. Thank you for joining this session. I hope you found it insightful. Let us continue our journey into the world of prompt engineering in the next video. See you there.